Hello, welcome to MGF 1107, also known as Explorations in Math. That is exactly what we're getting ready to do. We're getting ready to explore all kinds of topics in math, and it's going to be fun. You see the book there. We're currently using a survey of mathematics with applications, 10th edition. In the future, that might be a different book, but don't worry, still the same concepts, same topics. So let's go. Let's dive right into the first thing we're going to look at here. And that is problem solving. In current book, chapter 1, section 3, but again, if you're in a different book, don't worry, still same concepts. Okay, so diving into problem solving, we are going to be using a 4-step process as it is written here. In this 4-step process, the first thing you got to do is understand the problem. And understanding, well, how do you do that? Well, I know it sounds obvious, but read the problem. And I'll tell you, with all my years of math experience, I almost never understand what a problem wants the first time I read it. Even when I'm helping my son with his math, it's just usually I have to reread the problem. And sometimes I have to reread the problem. Just have to keep reading it until I know what it says, what the information is giving me, what it's asking, all of that. Like trying to filter out, do I even need all this information? And once I finish reading it and feel very comfortable with it, I then start setting it up. I draw a picture or make a graph or a table or chart. And I mean, not only does that help me organize my information as I label it, but it also kind of helps me relax a little bit because I know math problems can be kind of stressful. So, I sit there and if I draw like a kooky little stick figure, it kind of helps me relax a tiny bit as I'm setting it up. I label it with everything. If there's unknowns, variables, I label those and what they mean. And then in the meantime too, if I figure out I'm going to need a formula, I look it up and write it down as part of the figure. So everything I need, I start writing it down and drawing it and laying it out. Then in this process, as I'm doing this, I'm also devising a plan to solve the problem. That process of drawing and specifying variables helps me to think, okay, do I need to set up an equation or what do I need to do? What's my pattern here? Then I carry out the plan once I'm satisfied with it. If it's an equation, I solve it, or if it's some kind of thinking problem, I start tackling it and eventually come to some solution. Then I check my results. Probably the number one mistake students make isn't in solving the problem correctly, but is in not fully answering the question that's being asked. And hey, I'm guilty of it too. I've done that before myself. Even when I'm tutoring or teaching, I'll solve it and go, wait a minute, why is that not the answer? And it's like, oh, silly me. They were asking for this, so I have to go, a step further, or the way they, I have to go back and look at the way they phrased it, or look at what exactly is it they wanted, and make sure I've answered that. Make sure it makes sense. Check it over, plug numbers in, make sure they work, that kind of thing. And that's it. I mean, it sounds simplistic. There's only 4 steps, but that really is the process that you have to go through to solve math problems. Sometimes it takes long. On some problems it takes longer, but it's still the same 4-step process. And who can we thank for this? We can thank a man named George Polya. He was a math educator, educated in Europe, and taught at Stanford University. And he wrote a whole book on this called How to Solve It. The title is pretty self-explanatory. He outlined these 4 steps in problem solving and went through and discussed his process and discussed the thinking, the thought process that is needed in order to effectively, efficiently tackle math thinking. So we are going to tackle some ourselves. I'm going to pull a couple of problems from the current textbook, and I'm going to share some of my thought process about, well, how did I think this through? Okay, so the first problem that I have on page 32, and it's number 49. And what happens is they give you these 6 circles. And the circles are connected like this. And they ask you to place the numbers 1, 2, 3, 4, 5, 6 in these circles so that the sum on the 3 straight lines is the same. So when I first thought through this problem, I looked at it and I was like, oh, that's a cool figure. And as I was reading it, immediately my brain wanted to jump and guess like what it wanted me to do, but I made sure to continue reading, and it said, make sure the sum is the same along the 3 straight lines, and use each number exactly once. So, oh, that's a key. You can't repeat, you can't skip numbers. And then finally, the thing I didn't pay attention to at first, but on my second or third reading, I realized it said this. There is more than one correct answer. It's like, oh, that's cool. So once I find my answer, I can stop. But it's nice to know that not everybody's going to get exactly the same answer, but you can still be correct. All right. So I went through. I read the problem. So I read it. And then I started working on, starting to organize my information. And I was like, okay, so what can I do? What do I need to organize? So I laid out the numbers 1, 2, 3, 4, 5, 6. And my plan was to look for patterns and decide an estimated sum. Well, don't want too many big numbers together. Too many big numbers together. Or too many small. So I started laying them out, and I said, well, you know what? Maybe I can put 1 and 6 together, the extremes. Maybe go with that. Maybe somehow put 2 and 5 together, 3 and 4. But then I was thinking, and then I was like, will this work? Let's try it. All right, so then if I'm going to do that, let me see here. Let me draw those circles again. So there's my circles and my line segments. What the heck am I going to do with those? So I'm still thinking about it. Well, let's say I put 1 and 6 here. Oh boy, that's already 1 and 6. That's 7. I need to put 2 and 5 together. So maybe if I put 2 and 5 here. It's like, well, that equals 8. But that's not going to work over here. Or here. Okay, so maybe try different arrangement. don't want 5 and 6 together. Too much. Okay, so if I left 1 there, maybe if I put 6 and 5 like this. Okay. So 1 plus 6 is 7. 1 plus 5 is 6. And I've got 1, 2, 3, 4, 5, 6. I've already used 1, 5, and 6. So what could I add to those to get the same sum? What can I do? Maybe if I do 7 plus 2 and 6 plus 3. So put a 2 here, a 3 here. Works so far. So then how about if I did that, so the 2 and 3 are used. So now if I put 4 here, 2 plus 4 plus 3 also equals 9. Wahoo! Got it! There's my answer. Yay! So that's it. So maybe we can box that in. Yay! This is the one. This is the one we want. That worked out. Woohoo! So that's just a little Polya method there. All right, let's try another one. Let's try one more. I had 3 of them worked out, but you know what? Well, I could probably fit both of these in. So yeah, I'm going to do 2 more. Okay, so how about next we do the one on page 36, number 37. Okay, we've got dots. And it says, how many dots in the 100th figure? Often with problems like this, you're looking for a pattern with like positions and how many items are in each. So the first figure has 3 dots. Second figure, 2, 4, 5 dots. Third figure, 2, 4, 6, 7 dots. So my first approach, just based on experience, is I look at position, and if there's some kind of a pattern relating the position and the number of dots. Well, in the first little dot triangle it's the first position, and if you add 2 to that, you get 3 dots. In the second one, the second position, if you add 3 to that, you get 5 dots. In the third one, the third position, you add 4 to that, you get 7 dots. It's like, oh, wait a minute here. I might be onto something. This might actually work out for me. So, what goes on in the fourth position? Well, each time you're just adding 2 more dots. So fourth position is just going to be 2 more dots. But that's 4 plus something equals 1, 2, 3, 4, 5, 6, 7, 8, 9. 4 plus 5 equals 9. So notice that number we add, the position plus 1 more equals the number of dots. Like fourth position plus 1 more, which is 5, equals 9 dots. And the question didn't ask for the next figure, for the fourth one. I have to go back and make sure I've answered the question. It asked about the 100th figure. So the 100th position plus 101 will equal 201 dots. I am not drawing that. But there you go. Okay, so as I promised, I have one more. I love these kinds of problems. They're so much fun. I love looking for patterns. I love playing. I did some playing before I made the video to work these out, because obviously you don't want me spending too much time sitting here trying to work it out on the video. But I'm trying to still kind of share a little bit about my thought process. Okay, page 33, number 59. You're supposed to put digits 1 through 8. Exactly once each. So I'm paraphrasing for you. And no two consecutive digits can touch vertically, horizontally, and or diagonally. And they give me this figure. It kind of reminds me of being in the playground when I was a kid, when I used to play hopscotch. It's not a hopscotch board, it just kind of reminds me of that though. So it was like, you know, as I'm drawing this and trying to work it out, it kind of brought back that little childhood memory, kind of made me smile, which immediately helped me feel relaxed about doing this math problem. So I think I'm going to switch colors so you can see my digits, have them stand out. Let's do blue. So when I was first thinking about this, I'm like, well, I know that consecutive digits can't touch, so spread out consecutive as far as possible. That blue is not light enough, so maybe I'll switch to a different color. Maybe this purple color? Alright, so I'll use the figure I have there. And one of my first thoughts was, alright, what if I start with 1 here? Well, 2 obviously can't go here, 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 or here. So I was like, well, does it really matter where it goes? And I was just like trying to be extreme, so I put 2 over there. And then next for 3, well, 3 can't go here, 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 or here. So I thought, well, maybe I'll put it over there. You know, keep like bouncing back and forth. 4 can't go here, here, or here, so maybe I'll put it up there. 5 can't go here or here, so maybe I'll put it here. Maybe, and then I thought, well, 6 can't go anywhere there, so now I'm stuck. Where am I going to put 6? Because wherever all the spots left are touching 5. It's like, oh, that's not going to work. So I was like, okay, scratch that. A little trial and error again. No big deal. Nothing wrong with some trial and error. Doesn't mean you're doing anything wrong. And you know, be aware, some of these problems might take a few times. It might take a little time to figure them out. So maybe you have something like that. And then I thought, well, I thought about tic-tac-toe. That's what it kind of reminded me of. Middle start is an advantage. So I was like, you know what? Maybe I'll put 1 in the middle. And then that's actually going to work. That's actually might be promising, because by putting 1 in the middle right off the bat, I know I can't put 2 here, 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 or here. It's like, so just by the very nature of the rules, 2 is going to be pretty distanced down there. And then next, 3 can't go here, here, or here. So I was like, well, let me just try it there. Let me see what happens. And that worked out pretty well. But then 4 can't go. See, I'm wanting to like try to find different extremes as I bounce around. So try to space it. Everything needs to be spaced out as much as possible. 4 can't go here, here, or here. So I was like, I'll just put it over here and see what happens. 5 can't go here, here, or here. So it's going to go here. 6 can't go here. But then if I put 6 up there, that's not going to work because then 7 and 8 are going to, by default, be left there and there. So I don't want to do that. So I decided to put 6 here. And that way 7 and 8 will definitely spread out. Well, I can't put 7 here because then it would be next to 6. So I got to put it up here. And then that leaves this spot for 8. And I'm like, you know what? I've tried this a few times now. Let me double check. Let me make sure this is going to be okay. So I looked at my 1 and my 2. They're spaced out. Good. I looked at my 2 and my 3. They're not touching. My 3 and my 4 are not touching. My 4 and my 5 are not touching. My 5 and my 6 are not touching. My 6 and my 7 are not touching. My 7 and my 8 are not touching. Wahoo! This worked. So now I'm done. So there we go. So that's kind of my thinking process. Don't be afraid to try stuff. Don't be afraid to try and fail. That's part of the learning process. That's part of the problem solving process. It's all part of math. Don't be afraid to try and fail. Just keep trying it again. Sometimes it takes time. Is there anything else I can add? Well, maybe I'll say this. Maybe I will say, don't get discouraged if it takes time. Take some time. We all struggle at first. All. Including me, including your smartest person like Terrence Towle. If you don't know who he is, check him out. We all struggle at first, so don't let that discourage you. Math problems take some time. Try to have fun. All right, so be sure to check out the magic square discussion in Canvas. More fun. And thank you for joining me. Hope you guys have a fabulous day, and I can't wait to continue on this explorations in math.